Experiment title: half adder, full adder, half subtractor and full subtractor. Today's session we are going to discuss how half adder, half subtractor, full adder and full subtractor are simulated using Quartus 2. First click on the Quartus 2 9.0 version. Click on open. Quartus 2 window is going to open. Click on file, create new project. Check the details. Then choose the path to be given. Choose the folder. Then the VHDL project. Open. Give the new folder. Folder name can be same as the project name. You can give the experiment name itself as a folder name. ADE. Adder I can give. You can give your own name. Now click on open. So file name is chosen. Check the path. Now check the path. Directory is done. Now the name of the project to be same as the directory name, the folder name which you give, ADE, adder. The same name is taken as a file name here, ADE adder. Now you can add this. Next, check these details. Family name Cyclone, then the pin speed grade 8, pin count 240, then package PQFP, FP, all this. Once everything is done, click on next, then finish. Next, we need to create a new file where we can type the code. So file, click on new, click on VHDL file, say OK. Now you can type the program to be simulated. Write a VHDL code here. Type the program for half adder, half subtractor, then full adder, full subtractor. Here entity name should be same as the file name. File name is ADE adder, the same name to be given here. So same thing while terminating entity, end followed by entity name. Even in the architecture block, entity name should be changed. Architecture name of entity name is the same file name is given as the entity name here in the program. Check all the steps. Once everything is done, you can compile. So check the number of inputs, outputs given in the entity block. A, B, C are the inputs used. Then what are the outputs? You have written the equations here. Half adder sum, half adder carry, all that. Full adder sum, full adder carry, half subtractor difference, half subtractor borrow, then full subtractor difference, full subtractor borrow. Equations can be checked. Based on the design, you are going to find the output by executing these statements. So once the program is ready, you can next step, you are supposed to save this. everything is fine, you check it. Termination, everything. Now you can save the code. File name, same file name is used again. Now you can compile. Click on the compile symbol. Compilation is going to be done now. Report is going to be generated. Wait for a while. So if there are any errors, any typing mistakes, syntax error, it's going to be checked. Which line, which error is going to be displayed. If there are any errors generated, you can go back, change the code, again save it, and you have to run. Now full compilation was successful. Compilation is done now. Next, what is the next step? You are supposed to create a waveform file. So file, click on file. This time, new, click on new. I'm going to choose vector waveform file. So here you have to check for the number of inputs and outputs to be given. So now, what is the next step to be done here? You need to generate. Before generating the input or output, edit. Click on edit. You have to set the end time. You can set the time. What are the time? Yes, you can set it in terms of nanoseconds. Say 10 nanoseconds. Say OK now. Now click on the empty name here. Right click, insert, then insert node or bus. So you need to say OK, then list. We are going to display the list of the inputs and outputs. Select all that. Say OK. Now multiple items taken. Say OK. Now what is that you have to do? Save this. Now you need to give the values 0 or 1. Click on A, right click value, then choose clock here. Set the value now by typing the period. Say 1 nanosecond, say OK. Same way, click on B, right click. Choose the value, then clock, then set. 2 nanosecond this time. Little bit delay you can give so that 0, 1 you can make out. Click on C, same way, value, then clock. Set the value, say 3 nanosecond. Say OK now. So ABC input is done now. Next step. Now again, you have to check for, you save this as a vector waveform file. Say ADE adder waveform file is generated now. Again edit, check for the end time. Same thing, 10 nanosecond is set. Now assignments, settings, go for the functional, then say OK. Now processing, you can generate the functional. So function simulation netlist is generated now. Now again you compile, start compilation. Wait for the result, compilation result. 0 errors. Warnings you can ignore, only the errors are to be checked. Compilation is successful. Again next time, start compilation and simulation together. Now we are going to generate the waveform once the compilation and simulation is successfully done. Wait for a while. So some simulation and compilation is successful. So you can see the waveform now. See when ABC are 0, all output are 0. When B is 1, C is 0. When A is 1, B is 0, C again 0. You can see the output. You can verify these results with respect to the truth table. We have the Boolean expressions and the truth table for each of these half adder, full adder, half subtractor, full subtractor. So we can verify these results with respect to the